Pink Kangaroo 2021, question 25. Christina has 8 coins whose weights in grams are different positive integers. When Christina puts any 2 coins in one pan of her balance scales and any 2 in the other pan of the balance scales, the side containing the heaviest of those 4 coins is always the heavier side. What is the smallest possible weight of the heaviest of the 8 coins? The answers are going to be important here, and we're going to come back and check that one of these is possible once we've made some assumptions. So what I'm going to do is let the coins have the letters. So the lightest coin is A up to the heaviest coin, which is H. We're going to start by assuming A is 1. Now, it might not be 1, it might be 2, 3, or 4, but the process that we're going to do can be then changed if we don't get the heaviest coin to be a number that's in the possible answers. So if we assume A is going to be 1, what we're also going to do is assume that the lightest coin is always on the scale with the heaviest coin. Because what we want is we want this scale here. We want this heavier scale here to always have we're told it always has the heaviest coin. Then the combination, we want the lightest and the heaviest. And of any permutations here, then whatever heaviest coin that we've got as part of this set, we're always going to assume that we've got A. We've always got the lightest possible coin along with the heaviest of the 4 coins. It doesn't need to be the heaviest in total because we want any 4 coins, and it could be these 4, for instance, which is where we're going to start. So we're going to assume A is 1, and therefore we can create the inequality A plus D. So we're going to take these 4 coins to start with. We've got A plus D is going to be greater than B plus C. We know that we've assumed A is 1. So 1 plus D is going to be greater than B plus C. Now, the lowest number that we can have for B is a 2. So let's put a 2 there. The lowest number we can have for a C is going to be 3 because they have to be positive integers and they have to be different. So 1 plus D is greater than 5. Now, because we're greater than and not greater than equal to, D cannot be 4, so it has to be either 5 or greater than 5. This says it has to be greater than 5, but 5 subtract 1. So D actually has to be greater than or equal to 5. If you're not sure about that, this would equal D is greater than 4. The next positive integer greater than D is 5, which D can equal, and therefore it has to be greater than or equal to 5. This means that we're going to put in a 2 here, a 3 here, and then a 5 just here. So for E, we need to find E next. Again, we're going to put it on the scale with A. We've got an assumption for C and D. And the same logic applies here. Oh, sorry, 13. And that's 21 up there. And finally, if I can squeeze it in. No, 13. Let's try that one again. So H plus 1, F plus G. H is greater than F, which is 13, G, which is 21. Okay. So therefore, using A is 1, assuming that B and C are the smallest values possible after 1, then we get to a value of H is 34. And if we look back at our question, 34 is indeed a possibility. So we're going to call it C.